So this is 5.3, number 44, using properties of integrals. All right, what's given? There's some important information given, so let me highlight that. From 0 to 2, your function's always positive, and from 2 to 5, your function's always negative. And the net area from 0 to 2 is 6, and the net area from 2 to 5 is -8. I'm going to kind of draw a picture of what, I don't know what the graph looks like, but just to get an idea of what's going on. So I'm going to mark this as 2, this is 5. What might this graph look like? I don't know, but I'm going to do that. And I know the area of this is 6, and the area that's 8. Okay, I don't know what it looks like, but I know the areas because it tells me that. And I know that the function's always positive. It's always positive from 0 to 2, so I know it's always above the x-axis here. And from 2 to 5, it's always negative, so it's below the x-axis. So let's go, let's do this. 0 to 5. This is a very often used property. It's very important, and I will kind of draw a picture of how to do this. We have 0 to 2, we have 2 to 5, but we don't have 0 to 5. I know I did this on the video, but I want to show you here. I'm going to go A, C, B. If I have the integral from A to B, and I'm not going to put the functions in, I'm just conceptually, I just want to show this happening. So what's the area from A to B? We learned I can break this up into 2 parts. I can do that part and do that part and add them up, and it'll be the area from A to B. So that's going to be the integral from A to C plus, and then integral from C to B. That is a very common property of integration that's used on multiple choice questions. So make sure that makes sense. And you'll just know when to use it because you'll have, oh, 0 to 5, I have 0 to 2 and 2 to 5. You have all the numbers involved, 0 and 5, there's 0, there's 5, and the middle ones are matching. So that's your secret to realize what's going on. So part A, the integral from 0 to 5 of f of x dx, I can break that to 0 to 2 and then go from 2 to 5. I'm using that property. How does it work? 0 and 5 are the numbers, so I need a 0 and 5, and these have to be the same number, and it matches. So what is the integral from 0 to 2? That's 6. What's the integral from 2 to 5? That's -8. So I get -2 for part A. All right, part B. Let's do part B. This one's kind of tricky. So you have to understand, so to be able to do part B, conceptually, you have to understand what's happening. So the graph looks, I don't know, I know it has net areas like that. What does the absolute value do to a graph? An absolute value takes negative x values and makes them positive. So if you make those positive, it's going to flip it on top. And there's going to be an 8. So the green graph, that is going to be the absolute value function. So what's the net area of this green function? It's going to be 6 plus 8. It's going to be 14. So that's how they do that. The absolute value takes all negative values and pops it up on top. Now, I want to tell you why it's absolutely vital that you knew this, that the function is positive from 0 to 2 and negative from 2 to 5. Let me show you why that's super important. Let me erase this. I'm going to give you a situation. What if you didn't know that it was always positive and always negative? So from 2 to 5, could it not have looked like this? And your net area has to be 8. So I can say this is -12 and that's 4. So isn't the net area of that -8? Like they told you here? So if you didn't know that it's always negative on this side, what if it switched? When I absolute value that, watch what happens. So this is still 6. The absolute value function is going to take the negative, pop it up top, and do that. This would be 12. Then you do the net area, you add these up, you're going to get 22. Because part was below, part's above, so part's going to get flipped up. And so knowing that's underneath allows you to know that this is going to be 8 on top. But if you didn't know that it's all underneath, you could have portions below, portions above, and then your answers are all weird. So 14 is going to be your answer because this flips up top. So hopefully you can see that conceptually. Okay. Let me see. Let me go to part C. So the rule for this, you're allowed to take a constant and put it in front. So that's going to be 4, 2 to 5, f of x, absolute value, dx. Now here's 2 to 5, but you're absolute valuing 2 to 5. So 2 to 5 is going to get flipped up here on the absolute value, so that integral is going to be positive 8. So this is going to be 4 times positive 8, even though the original was negative 8. Because the absolute value, conceptually, you know that the function is now above the x-axis, making it positive 8. So the answer is 32. And then part D, what rule are we using there? Let me erase that. So part D, you have 2 functions. You have a rule that says you can break that into 2 separate integrals. So part D, I'm going to rewrite it as the integral from 0 to 5 of f of x dx plus the integral from 0 to 5 of absolute value of f of x dx. So the other rule, you could split integrals of sums into sums of integrals. Well, what's this integral? We already found that. That's negative 2. And what's this integral? We already found that. That's 14. So your answer is 12, and we are done.